Good morning everyone. Welcome to the class of antenna and wave propagation. This is video lecture number 4 and we will continue with the topic spherical coordinate system. Now see this one, spherical coordinate system. In this spherical coordinate system you will see that coordinate points are r, theta and phi. In the last lecture we have discussed about we have started the spherical coordinate system, and here we will continue with the spherical coordinate system. You will see here that this is point P, let's say this one is point P, and this point P is represented in Cartesian coordinate as x, y, z. In cylindrical coordinate system it is represented as r, theta and phi, and in this spherical coordinate system this same point is represented as this is spherical and this is cylindrical. Now see, the distance from the origin to the point is given by the r. R is the distance from origin to the observation point P, and phi is the angle phi is the angle between the positive x-axis to the point of projection of point P on the xy plane, and this always goes in the anti-clockwise direction. Anti-clockwise. And theta is the angle between the positive z-axis to the point of observation, that is P, and it can move from in either direction. It can move from anti-clockwise or it can move from in the clockwise direction. Means theta can move from anti-clockwise and clockwise, but it always move from what? Always move from top to bottom. It always move from top to bottom. Clear? Now range of r can vary from 0 to infinity, where phi ranges from 0 to 2 pi and theta ranges from 0 to pi. Because if I say if these all are variables, I can say that sphere will be formed. Or you can say if all are variables or all are constant, sphere will be formed. Clear? Now see, if I say a vector, if I have to represent the a vector in spherical coordinate system, then this a vector in spherical coordinate system is represented as ar a cap r plus में a theta a cap theta plus में a phi a cap phi. Now point of transformation, if I say, see this one, from this figure you will see that from C you will see that y equal to rho sin phi, x equal to rho cos phi, and from this triangle you will observe that rho equal to r sin theta, because this is rho and same this one will also rho. So this rho equal to r sin theta, and this z equal to r cos theta. Now we will see that z equal to r cos theta, y equal to x equal to what? X was what? Rho cos phi, and rho is equal to what? Rho what is what? In the last slide we have seen that rho is what? R sin theta. So just put this rho equal to r sin theta multiply by cos phi. You will see x equal to r sin theta cos phi. Similarly, y equal to r sin theta sin phi, and z equal to r cos theta. Now just squaring of equation number 2 and 3 and 1, 2 and 3, and add these two equations. Equation number 1 square, then plus में equation number 2 square plus में equation number 3 square. You will get what? You will get r equal to under root of x square plus y square plus में z square. You will use the identity that sin square theta plus cos square theta equal to 1. This identity will be used. Then you will get r equal to root of x square plus y square plus z square, and on dividing these two equations, you will see that theta is equal to tan inverse of rho divided by z. Divide these two equations. Rho equal to r sin theta and z equal to r cos theta. Divide these two equations 4 and 5. You will get theta equal to tan inverse rho divided by z, and rho is what? Equal to root of x square plus में y square. Clear? And similarly phi will be equal to, divide these two equations, you will get phi equal to tan inverse of y by x. Clear? So these three equations are very important for point transformation from spherical coordinate system to Cartesian coordinate system or vice versa. Now we will see the vector transformation from what? From Cartesian coordinate system to Cartesian to spherical. Now see that at this point you will see that this one is r. You will see that a cap r will be in this direction and phi is in this direction. Similarly phi will be a cap phi, and theta is moving from top to bottom. Then you will see that theta will also, a cap theta will also be in this direction. Now see that a cap r, ar equal to, you will see that a vector is equal to what? Ar a cap r plus में a theta a cap theta plus में a phi a cap phi. So ar will be ar a cap x ax का dot a cap x. This point of equation will be formed, and transformation you will get this matrix ar equal to a theta a phi is equal to sin theta cos phi, sin theta sin phi cos theta, and minus cos theta sin phi. Or you will see that once you will get this equation, differentiable of this equation with this one, you will get this one, and then this equation you will get the differentiation. Clearly? Similarly, if I have to transform from ar a theta a phi to ax ay az, just you have to do the transpose of this equation. transpose of this matrix. Transpose of this matrix, you will get this one. Now next one is the constant coordinate surfaces. Constant coordinate surfaces, if I say that, let's say this one is Cartesian coordinate system x comma y comma z, and you will see that we have studied that the x varies from minus infinity to infinity, y will vary from minus infinity to infinity, and z will vary from minus infinity to infinity. Now if I say that x is constant and y and z are variables, y and z are variables, then you will observe what? If I say x equal to 3, y is variable and z is variable. Now you will see that x is equal to 3. It means somewhat 1, 2, 3. You will get this one is 3, and the plane, a plane will be formed, and that plane will be what? That plane will be what? Will be what? Parallel to y and parallel to z. You will get this one plane. In this, y is variable, it can move from minus infinity to infinity, and z will move from minus infinity to infinity. So you will get this plane. Clear? Now similarly, if I say the z and x are the variables, what will the plane formed by the when y equal to constant? And in the now see this one, in the next slide we will discuss about each plane will be which will be formed. Now see that range of variables in cylindrical coordinate system, that rho will ranges from 0 to infinity, phi will range from 0 to 2 pi, and z will range from minus infinity to infinity. And this spherical coordinate system, we have already said that the this r distance, when r is the what? Radius of sphere, ranges from 0 to infinity, theta will range from 0 to pi, and phi will range from 0 to 2 pi. Now you will see that if I say this one is the constant coordinate surfaces for the Cartesian coordinate system. Now see this one, if I say x is constant, y and z are variables, then which plane will be formed? The plane will be formed as this one. Means if I say this one is the rectangular coordinate system, this one is x, y and z, you will see that this front view plane will be formed. Now if I say that y is constant and x and z are variables, which plane will be formed? Y is constant, means if I say this y is constant, and x and z are the variables, x this one and z this one, you will see that this plane will be formed. Means if I say front view cuboid ka, and this plane will be formed when, clear, or you will say this one. Means plane, यहाँ पे plane कौन से form में बनेगा, YZ plane, and here plane will be what, XZ plane. And when Z is constant, X and Y are the variables. When Z is constant and X and Y are the variables, then which plane will be formed? This one. This plane will be formed. Means the top view or ground. The plane will be what? XY plane. Clear? Now see, in the cylindrical coordinate system, if I say in the cylindrical coordinate system, if I say rho is constant, rho, phi, z, and phi and z are the variables, the plane will be what? Phi z plane. Because if I say rho equal to 3, cylinder will be formed. Overall what? Cylinder will be formed. Rho equal to 3 and phi and z are the variables. So we will see that this cylinder will be formed. Clear? Circular cylinder will be formed. Circular cylinder of radius constant. Now if I say that phi is constant, means phi can be 120 degree, 30 degree, 40 degree, and rho and z are the variables. So what it will be? If I say phi is constant, phi constant है, means ये angle constant है, then plane will be formed what? This one. You will see that this plane will be formed. Clear? When phi is constant, a semi-infinite plane with its edge along the z-axis. Clear? Now see, if I say that z is constant, when z is constant and phi and rho are the variables, means the height of the cylinder now is constant. Height of cylinder is constant, rho and are the variables. Then you will see that height is constant and this one, इस तरह का एक plane form होगा. You will see this one. So when z is constant, infinite plane as in the rectangular coordinate system. Clear? Now for the spherical coordinate system, if I say spherical coordinate system points coordinates are r, theta and phi. Now if I say that this is sphere and this is what? R. If R is constant and what? Theta and phi are the variables. Theta and phi variables. What will be formed? R is constant. If I say R is constant, R equal to 3, and theta and phi are the variable, means sphere will be formed. Sphere will be there of what? Of constant radius. Now if I say that theta is constant, another maybe that if I say theta is constant and R and phi variables, R and phi are the variables. Now see that theta is constant. Theta is constant means it can be this one, and R is variable and phi is variable. You will get what? This figure will be formed where theta is constant. Theta is constant. You will see that the circular cone with z axis as its axis and origin at the vertex. Now see, if I say phi is constant and what? R and theta are the variables. When phi is constant, R and theta are the variables. You will see that this figure will be formed, and this figure will be what? It is just like a circle is formed. Okay? Means if I say a semi-infinite plane as in the cylindrical coordinate system, it's just like a circle is formed. Clear? When phi is constant. Now next one is the vector calculus. Next topic is the vector calculus. First we will discuss about the differential elements. In the differential elements means a small part of the length a small portion of surface and small portion of what? Volume, which can be represented as, if I say L, represented L, that is dl. Surface is small portion will be ds. Surface volume and the differential part, small part will be what? dv. Clear? Now in differential elements there will be differential length, differential area, or you can say differential volume, and this differential volume and differential area and differential volume. Clear? Now in the vector calculus you will also study about the, now I have already taken the small part of length. Now I will see that if I integrate the small part of length s and volume, you will study about the line integral, surface integral, and the volume integral. Now first we will study about the differential length, differential area, and differential volume for the rectangular coordinate system, or you can say for the Cartesian coordinate system. Now see this one. This is coordinate system. If I say this is a cap x, this one is a cap y, and this one is a cap z. At this point, if I take a zoom part of this point, you will get what? Some sphere, rectangular field will be formed, because I am talking about the rectangular coordinate system. I am just इस point को I have zoomed at this point. You will get the, you will observe that the cuboid will be formed. Clear? Now see that if this is x, you will see that this one will be what? Dx. Similarly, if this is z, the small part of this z will be what? dz, and y is in this direction, you will see that this one is the dy. Clear? Now if I say differential displacement, this one is the length. If I say this one is the length from origin to this point P, the small differential length will be what? dl, means from this point to this point, यहाँ से लेके यहाँ तक का. Clear? Or you can say small part of this one is what? dl. Is length, this is length, small part of this length will be what? dl. So dl will be what equal to dx a cap x plus में dy a cap y plus में dz a cap z. How? Now you will see that if I say for differential length, if I say x is variable and y and z are the constant, so you will see that dx a cap x now if I say y and z are the constant and the y is variable, so you will see that dy a cap y, similarly dz a cap z. The differential length will be equal to dx a cap x plus में dy a cap y plus में dz a cap z. Now differential volume, differential area. Now if I say differential area, area will be what? Area will be of what? Surface. Area will be of surface. Now see that if this is a cuboid, so this one is the area of surface. Now for this plane you will see that, for this plane you will see that what? One y is what? You will see that y is constant and z and x are the variables. When y is constant, x and z are the variables, you will observe that ds will be what equal to, if this is z, x and this is y, you will from differential area of this one will be what? dx dz. Clear? And unit vector will be what? Unit vector will be of in this direction, that will be a cap y. So ds of this area will be what? dy dz, sorry, dx dz a cap y. If I say the differential area of this one, you will observe that, see that what? X is constant and y and z are the variables. When y and z are the variables, x is constant, which means their differential length will be what? dy and dz. This is dy and this is dz. So area of this one will be what? dy into me dz a cap x. Now for the for this area, differential, if I say differential area of this one will be what? You will see that dy dz and its unit vector will be always perpendicular to the surface area. Always remember that the unit vector in the surface area that will be perpendicular to the other two variables or perpendicular to the plane. Clear? So will be dy dz a cap x. Now if I say this is whole cuboid will be formed, and if I take a small part of this cuboid will be what? Another cuboid. Now if I want to calculate the small volume of this cuboid, small part of this small volume of this this small cuboid will be what? dV equal to dx dy dz, where x, y and z all are the variables. Clear? dl and ds are the vector quantity, their result will be what? Vector quantity, and dv will be the scalar quantity. Now in the next lecture we'll continue with the differential elements in the cylindrical and the spherical coordinate system. The references which I have taken, that is Principle of Electromagnetics by Matthew and Sadico. Thank you.